great to see you here. I can tell that even things have some casualties out of the virus discussions on Earth, because there are quite a lot of people who never showed up today, unfortunately. But we have great people here. Only the strongest survive, and we're all here. The best guys are here, and we're going to enjoy 5 presentations today on the topic of robotics. And as you probably know, I hope I recognize a lot of you, so I think most of you know the format of what we do and why we do this. The things which we started actually 6 years ago in this place, we try to learn together how to transform innovation in small companies to value creation. That's the only thing we do. People believe this is an incubator, that's the only case. This is the only case where perception is not the reality. We don't do that. We rent out space. That's our business model, because we don't take any money from the government. So that's kind of things. And one of the things we do to make people learn about new things and interesting things, to make people inspired about what's coming, which is really important, to get new relationships into those areas, and also to get a lot of information that you need to hear. Or is to ask a couple of people who spent a lot of time on the topic to share what they've learned rapidly. So that's how we try to get people on top of what's going to come. And I think that gives us, hopefully, an advantage over all the others, because we have more people who are on top of things earlier, hopefully. So without any further ado, and this is high pace, not very kind of strict or formal. When you have questions, maybe we don't have time for questions, and then I don't allow you to raise questions. But when you have a question, please introduce yourself so we know who's talking. That's kind of the only rule. So our first company to speak is sorry. They are from Things, actually, which is extra good. They work here in the building, and they are Robotics. Welcome, Fredrika.
Thank you.
And you have to you know how to put it here. That's the trick.
Yes. Let's see. Redo? Eller ska jag dra den där lite? 1 second. Funkar det sån eller? Ja. There we go. Sorry for having to wait. Yep. Okay, we're ready. Okay, hi everyone. I'm Marcus, and this is Fredrika, and we are from Relox Robotics. So we develop mobile autonomous robots, and in this presentation we're gonna start with telling you a bit about what we're doing, who we are, and why we're doing it, and then we're gonna go over to hopefully giving you some advice and tips and tricks that we have learned during our journey with this company. So let's get started. So here you see a range. That is our first customer, or place for our robot. And this one is a bit larger than what they commonly are. But here people are standing in a long line, hitting golf balls on a large field. And over time, these balls get spread out randomly on this field, and somehow they need to be collected. So how do they do it? Today, they have like a tractor or a golf cart that they use to collect these golf balls, and they also have a trailer in front of the cart that collects the balls. In some cases, they actually have even simpler equipment. So in the top right from you, you see Fredrika testing one of these more simple ways to collect the golf balls. And as you can imagine, it's quite time-consuming doing that compared to the picture that I just showed you. So we simply want to replace this time-consuming, costly, and repetitive and boring job with a fully autonomous robot instead. So we are using a high-precision GPS solution called GPS RTK to move around on the field. And that gives us a lot of advantages. So we can optimize the path that the robot is taking depending on where the golf balls are, etc. And we also have a stereo camera and a bumper on the robot to avoid hitting objects such as signs or flags on the golf field. And then we're also using a 4G, so we can do over-the-air updates to the robot. And this is the team behind it. So it was me and Fredrika who started this, and it was 4 years ago while we were studying at KTH. And quite quickly we were two of our classmates, Isak and Martin, who's here in the audience. They also joined this journey. And we also got into KTH Innovation while we were studying. And then eventually we got into Sting. And then for over a year now we've been here at Things. So we have a room just above us that we are sitting. And quite quickly there was a lot of more work than just building the robot that we think is the fun part. So we had to have more people helping us with like building a company. So that's why we hired a CEO called Fredrik, who has some business background. And then we also hired a guy called Mats, and he's helping us with sales and partnerships that we have. So where are we at now, you might wonder? At the moment, we have our minimal viable product finalized. So now we have started testing it on a golf course here in Stockholm, which is one of our first customers. So once we have done all of the tests that we feel are necessary, then we are ready to deploy more robots in Sweden primarily to start off with. And we already have several customers who are waiting for this type of product. So that was a bit about the company and what we're doing.
Yeah, so it's been quite a long journey from idea to MVP. And here you can see some of the iterations that we did along the way. And we've also encountered quite a lot of problems during this journey. And today we wanted to share some of these with you so that you don't fall into the same pitfalls that we did. So if time travel was possible, we would like to go back in time and give ourselves a couple of advice to save ourselves a lot of trouble. So first advice is don't do everything from scratch. In the beginning, we did basically everything ourselves, and this picture illustrates this pretty well. So we had a need to remote control the robots, and we solved this by making our own radio controller using a piece of plywood, an Arduino that we programmed ourselves, and we put everything together on a prototype board. And looking back, this was clearly not the best solution. So why did we do this? I think one of the reasons was that we just wanted to prove that we could. We wanted to solve all the problems ourselves, and we were very eager to find quick solutions. And another reason might be that we just didn't really know what to search for. So the solution that we ended up using later is this other RC controller that is actually used for our flying drones. So it's not really the first place to look. So my advice here would be to spend a bit more time in the research phase, look into different ways to solve a problem, and not just start implementing the first thing that comes to mind. And furthermore, this is not even a part of like the core functionality of the robot. So this is just a device that we use to make the testing procedure easier. So I would also tell ourselves to focus more on the core functionality and not get sidetracked by projects like this. And even from an economical standpoint, it doesn't make sense. Because even though this controller is a bit more expensive, or a bit pricey, then the development cost for our own RC controller, if we calculate like 360 Swedish kronor an hour per person, and then maybe one day 2 people to finalize this, and maybe 300 for component cost, then we end up in more than 6,000 Swedish crowns, which is way more than the controller. And the second mistake that we did a lot was that we were afraid to change our design choices, even though we started to realize that they might not work out. So for a long time we used hub motors, which is on the left picture here. So it's like a wheel with a robot or with a motor inside it, which was very appealing to us because then we could easily mount it on a chassis and there would be no moving parts inside the chassis. So we liked that design very much for those reasons. But we quickly encountered 2 problems with the hub motors. The first being that it was difficult to find a model that had enough torque, and the second one was that they do not often come with encoders with high enough resolution, which we needed to get position and velocity feedback. So we tried to find workaround and fixes for these problems, and we created a lot of like ad hoc solutions, but all of these just created more problems in the end. So what we should have done here is really to take a step back and see what other solutions that exists. And don't stick to a bad idea just because you already spent a lot of time on it, even though it's very easy to do that. So in this case, the alternative solution was to implement a full like powertrain, including a wheel, motor, gearbox, encoder, and brake. And in the beginning, we were afraid that this would be more mechanically complex and it would take too much implementation time. But after a little bit of research, we realized that we could actually make the solution quite compact. And the powertrain that we're now using, you can see in the picture to the right. And it doesn't take up that much more space, and it's quite easy to mount. So that was definitely a change worth doing. So those were some of the mistakes that we made, but there were actually some things that we did well from the beginning. So we realized that even though our idea was quite simple, the execution was difficult because you need a lot of knowledge in both mechanical construction and electronics and programming, and a team of just 4 people on tech side could not have expertise in all those fields. So instead of keeping the idea secret, we had an open approach, so we talked a lot about it to different people, and that gave us a lot of benefits over the years. So for example, we started talking to golf clubs very early on to see what they wanted out of this product. And we quickly found out that we have one competitor already on the market, and they're called Robotics, and then they're in the top picture here. And we heard that there was one golf club in Stockholm that already had a solution implemented. So we went over there to have a chat with them, and they gave us some very valuable information about this product because they weren't completely happy with it. Because firstly, it was just like too small and didn't have enough capacity. So they would still have to go around with this tractor and manually collect the balls. And also, since it's only like, it's just one robot and it collects the balls inside the robot and drags along dirt, etc. So it would need quite a lot of maintenance for that reason. So based on this feedback, we could make some pretty good design choices quite early on. And we decided that we wanted the ball picking mechanism separate from the robot. So we contacted the company that makes these ball collection trailers that are used with the tractors today. And we found out that they're actually like the world leading company of producing range equipment, and they're located here in Sweden. And after talking to them a little bit, we found out that they're interested in our robot as well. And today we have like a pretty successful partnership with them. So they will do the production of our robots, and they also have a huge sale or customer network that we can access. So by this partnership, we can still focus on the parts that we find interesting, and that is developing better robots.
Yeah, so that was just a quick presentation from our part. Hopefully you got some tips and tricks how you can easier make a hardware related product. And we're gonna be around, so feel free to talk to us afterwards if you want some help that we might be able to help you with, or if you want to know more about us. Thank you.
Brilliant. Westinghouse fuel factory in Västerås. Have you considered having a mentor that would give you that advice? Could you get that now?
Yes, like we have so that's something that we realized later on. So we didn't have one in the beginning. But now we've been in contact with many different people. So we try to ask for help whenever we encounter a problem. But for example, we have a PhD student up at mechatronics that we have meetings with quite frequently.
Well, I was
And,
more thinking, you're a typical KTH student,
mhm.
like myself. Just very technical focused.
Yes.
In the end, you need to sell it, like you said, you have a CEO. So this is what I would expect from a mentor, have this overall view. Okay, you both need a product and perhaps find a company and blah 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 blah. All this,
Yes. So, no, but that's partly when we realized that we needed to expand the team when we hired Fredrik. So he has that role a little bit, but yeah, on the tech side, of course, there is still need for mentors.
But now you have a very senior person in the board, I know. He's
Yes.
very good, if you ask me. He's
Mhm.
very good mentor. So I think you're right. It's very important. You navigate very well. I'm really happy to have you here. And it's funny when you describe your journey. It sounds like it's 35 years, but it's rocket speed. So great. Thank you so much. So we have to move forward.
Yes.
James,
Thank you.
Next speaker is James from also a company in building, actually. I think this is the event ever with most speakers from the building, which is extra good, I guess. Waysure, take it away.
Yeah, thank you for the introduction. Hello everyone, my name's James Tidd. I'm CEO of a company called Waysure. We also sit on the top floor here. We also work with real-time kinematic, RTK, high accuracy positioning systems. I'm not going to talk about Waysure very much. I'm going to talk about a project we were involved in called ProPart. We're focused very much on autonomous vehicles, so trucks predominantly. And this project was an EU-funded project, along with Scania and other actors, to have a high accuracy positioning system for automated trucks. So what the project was about, Horizon 2020, if you're familiar with it, EU funding under the Innovation Action umbrella, funded by or controlled by the GSA. It's very highly Galileo influenced our project, Galileo being the European satellite system for navigation. We worked on it for 2 years, 3.5 million euro budget, of which 3 million was a grant. Thank you very much, EU. So I mentioned trucks. I'm sure you're all familiar with autonomous vehicles, be it a Tesla or a golf ball picking robot or a truck. Trucks have a disadvantage. They have a trailer. If you ask a truck manufacturer, it's a large, dumb block that they have to drag around. If you ask a trailer manufacturer, they don't have the same opinion. But it does block the view. It does occlude sensors behind you. The shape of the truck is also a problem. It's bigger. Lanes on a motorway don't get any wider just because your vehicle is wider, which increases the accuracy demand. Articulation, so because you have a trailer that can move in a hinged manner with respect to the tractor, then you have to take that into account. This picture on the left is trying to represent two large blocks that you have to treat as two connected but separate objects. And relative movement. This is related to size. If you put a number of sensors on a large vehicle, how they move independently of one another actually impacts your accuracy. So if you imagine the cab of a truck, there's a lot of suspension, and the cab can move quite a lot with respect to the chassis. So a sensor on the top of the vehicle waves around effectively compared to the wheels on the road, which is a difficult problem to solve and very much dependent on the how the truck manufacturers decided to implement their stability system and their suspension. However, trucks do have an advantage. I've talked about technical disadvantages. Here I'm going to talk about more business rollout of autonomous vehicles advantages. So trucks have and continue to work autonomously in controlled areas. So mines, ports, depots. If you've seen Volvo, they've announced Brønnøy in Norway, which is a autonomous truck taking chalk or lime from a mine face to a depot. Because it's a controlled environment, you don't have to have the same safety requirements on the system. And another, with the type of industry that you have, trucks are very, very much in use there. However, when you're in a controlled environment, you do want to take that produce somewhere else. And that's why motorways are the next key thing for trucks, hub-to-hub transport, whether it's port to a logistics center or a mine to loading a boat or something. It's a commercial application, so there aren't very many private people who have a truck. Which means it's a business-to-business model. It means that you can facilitate selling your service, whether it's transport as a service or you sell an autonomous vehicle to a customer. That's much easier to get that service out to the market. And they're already doing highly autonomous operations already. So it's not a new thing for their customer base to accept. If you liken it to Uber and things like that, it's a new model for private citizens, whereas commercial customers are already used to this type of application. There's direct benefits as well. You can run the system continuously because your drivers don't have to sleep if we talk about long distance haulage. You remove the driver, potentially, depending on the application. In mining, they've removed the driver for some applications. And safety, the immediate benefit for reduction of cost due to accidents and bad publicity due to accidents and everything. So there are key advantages. I guess the point of this slide is really to say, in my opinion, autonomous trucks are going to happen in Europe much faster than the Waymos, the Ubers, etc. Because the commercial reasons are there, the familiarity with the technology is there, and I think the rollout is going to be geographically limited, that it's going to happen in mines, depots, and then on motorways, and then we'll look at taxis taking you from Östermalm to Arlanda or wherever it may be. Sure.
Could you elaborate on the safety in controlled environment on motorways?
It's not a controlled environment, but you can limit the access to it. There's on-ramps and off-ramps. Compared to children running between cars, it's a safer environment. And I think it's going to be a stepwise increment. The technologies, they're not perfect, and they're going to handle these controlled, less complicated environments first. And legislation is going to allow for it. And there's a lot of other reasons as well. So the use case from the ProPart project, it was an automated lane change. The reason I've built up to this is people will say, well, Tesla, you can do that today. Teslas can see behind them, which is one of the key things with an automated lane change that trucks can't do. They don't know if there's a fast approaching vehicle in the same lane likely to overtake, which is represented here. It's mainly for an on-ramp, so when a vehicle wants to merge into regular traffic from an on-ramp, the truck needs to adjust its speed or change lanes to accommodate this entry of a new vehicle. So if you're all familiar with robotics, I'm sure you're all familiar with this. Sense, perceive, plan, and act. I've added test. When we're talking about real products, we actually need to verify that the whole system operates even in unexpected environments, as one would expect, or safely at least. I'm going to focus on sense and perception, which is what Waysure were involved in predominantly. I've listed the partners and their main responsibilities. Scania effectively were right through the system as the platform owner, but specifically they worked on the planning aspect and the implementation of the recommendation to change lane or brake or whatever was decided. So focusing on sensing, high precision positioning is what Waysure delivered along with Fraunhofer and SAIT, which is a Spanish research institute. We use GNSS. We get to about 2 centimeters absolute accuracy. It's the same system that Relox introduced, RTK INS. We do it in trucks, which has its own unique problems. We also use ultra wideband, which is a local ranging. It's still a radio frequency positioning technology, but it's good to augment GNSS. As you can see from the picture, GNSS suffers from multipath occlusion and various other things because the satellites are, well, it's like trying to see a 20-watt light bulb that's 21,000 kilometers up in space. It's quite a weak signal when it gets to us. We also use inertial sensors, gyroscopes, axes, magnetometers, barometers if they're good enough, and vehicle odometry, wheel speed or differential wheel speed. Putting all that together gives us very accurate position, velocity, attitude and heading, which is required for trucks. Surround sensing, so positioning is great, but it doesn't tell you where anyone else is. So you have to be able to see. In the application, we used a long, medium range forward-looking radar, side-looking radars, and a camera. We had LiDAR, but we weren't allowed to use it. Maybe a little aside, being a small company working with a large company, your access to specific parts of the canvas or data is very limited because, of course, they have their own relationships with other suppliers of competing or similar technology. So if you are looking to work with large companies, there is some friction there. Obviously, it's still beneficial, but just a heads up. So the infrastructure, what we put in place so that we could see behind the vehicle was a traffic radar on the side of the road. This is the traffic radar here. This is an ultra-wideband unit, which we used for the local ranging. But we also put GNSS corrections. To get down to the 2 centimeters, you need a correction service. And we put that in the infrastructure. Now, the purpose of the project, or the goal, isn't to suggest that at every on-ramp there will be roadside infrastructure. There are some people implementing that in Austria, in Hungary, in Italy. But it is quite a large step to take to expect that there'll be a radar at every on-ramp and off-ramp. This was really to display that if a truck can see behind itself, even from someone else's information, then it can operate safely. So perception, when you combine all of this information, position with respect to a map, onboard sensors, offboard sensors, what does that tell you? Well, hopefully it tells you if there's any vehicles in the lane which you wish to merge into or ahead of you. Key to understanding the perception is, can you associate objects? So without getting into too much detail, if you see a car in front of you and the traffic radar also sees a car in front of you, is it the same car or is it multiple cars? If you don't have good enough accuracy, can you associate all of these different objects that you're seeing around you? And how well can you track them? Does having more information about something mean that you know where it is more accurately? The results, there is a YouTube video which I can share with you. This is the highlight, which is that the driver was hands-free through the whole trial. And I'll speed it up. I understand I've probably taken longer than I should. The result of the trial was that the truck, throughout the whole test, could drive autonomously with a look, no hands, move from the driver. Braver than me. Those things are pretty scary, and they turn pretty sharp. So that was the result of our trial. I'll go into some of the lessons learned. So for us, whether it's combining sensors that are in the same platform or on a different platform, having a shared reference, which means lever arms, for those of you familiar with it. If a sensor's on a remote part of the vehicle, you really have to make sure you understand where that is with respect to the center of the vehicle. You also need a shared time base. If you're told where something is, that's great. If you're not told when an event happened, it's pretty much useless. If you're told when it is, but it happened ages ago, it's pretty useless as well. So whenever you're designing a robotic system, all your sensing elements really need to be low latency, and they need to be synced with one another. Otherwise, the information is, it's not useless, but it's certainly less useful than it should be. And then when you're in the real world, when you're driving a truck and hoping that it doesn't hit two safety cars that are beside it, you need to look at interoperability. So does it only work with a specific roadside sensor and a truck, or do you have to implement standards? We work with standards agencies throughout Europe. There's a huge political mess at the moment between G5 and 5G, those of you familiar with that discussion. We try to keep ourselves at arm's length from that. There's obviously, in Sweden, there's two camps even within this relatively small country. But for this system to really work, everything needs to be interoperable. Security, we pass data around quite freely without the fear of anyone trying to spoof or jam our signals. In the real world, there has to be better levels of encryption or detection of those types of activities. And then verification. Demonstrations are great, but how do you prove it's never going to go wrong? The safety requirements for cars are at a certain level. Trucks are even more so, and trains and planes even more so again. But if you can't prove to someone that your system is safe, then it'll never get into the market. And verification leads into understandable AI and other aspects that need to be verified, but specifically for the sensors, even there you have to have enough data so that you can prove your system. It's not good enough to show it works. You have to prove it doesn't break. And that's a very hard task on its own. Sure.
This verification, how did you do this? How did you work on the verification?
We did the demo, and we've set things up so that we are in a position to collect enough data. How we do verification is we try and predict the problems we'll find, and we build test cases around them. So we've done some of that, but we're not confident enough, or we don't think we're good enough to have found every possible bug that could be in our code or environment that we should operate in. Sorry, the
Authority acceptance. How do you make the different countries the authority?
Oh, okay. Yeah, I spoke about this on Monday. Standardization, both of the information that's passed around, but also how you validate and prove that each of these systems. 3GPP does it very well, which is the mobile, I guess, equivalent to transport system authorities. They specify a standard, a performance specification, and a test protocol. I think transport systems need that. It's going to be a lot more pushing and shoving and political wrangling there, but you can't specify an API and a performance spec without a test, in my opinion. Sure. So GNSS, or the positioning system. Oh, sorry, I'll repeat the question. So the question is, how would a system like this work in adverse weather conditions? Is that paraphrased? Okay, okay. Different sensors have different reactions to different weather types. We didn't use LiDAR, but camera can obviously be snow blind. Radar is somewhat more immune to weather conditions than others. GNSS, funnily enough, suffers when it's really sunny, because the ionosphere affects the signals from the satellites, and as the solar energy excites the ionosphere, it causes more variation in the air. It doesn't cause a large variation in the air that we can't calibrate out. So each sensor set has different reactions to different weather, and what people are banking on is the hybrid solution. The fusion of those is what gives you a robust system. My personal opinion is that there will be operational design domains that as soon as it's snowing, you'll drive to the side of the road, because with this geographic rollout of confined areas, the motorways is also going to have limitations to weather conditions, night, day, for example, snow, no snow. So I expect weather to have limitations just like a geofence on operation would have as well. So that actually somewhat concludes my presentation. Happy to take any questions if we have any time now, or sure.
Yeah, quick one. You mentioned latency, which I think is crucial, and everyone's talking about the cloud, but if you're going to be autonomous, isn't really the cloud out of the question? Too much delay?
It depends on the type of information. If you take HD map data from the cloud, I think that's fine. If you take information about traffic jams and signal phase and timing from further away, that can be on the edge, maybe even on the cloud. But if you want perception sensing, so the high rate stuff, pedestrians jumping out from parked cars, that has to be local. Yeah.
Great.
Thank you.
Thank you so much. And our next speaker is Sofia, with partner from Bioservo. Now we're into a completely different application of what I would call robotics.
Hi, my name is Sofia Sandberg, and I work with sales and marketing at Bioservo Technologies. And we have been developing exoskeletons since 2006. And today I will tell you about Iron Hand, which is our industry glove, and also about our journey to where we are today. And our goal at Bioservo is to prevent strain injuries in industries. So Iron Hand is it's the world's first commercialized robotic glove. It's a soft and active exoskeleton, and active means that it's driven by motors. And simply said, Iron Hand allows industry workers to use less grip force when performing grasp-intensive, repetitive, and static work tasks. So if you come up here. So now you can see what the system looks like on my colleague. And the system is equipped with pressure-sensitive sensors on the fingertips and artificial tendons that runs through the cord back to a power pack where the motors and the battery is placed. So we are a company from Sweden. We are located in Kista here in Stockholm, and we are about 30 employees today. And we were founded in 2006 as a project between two professors from the Royal Institute of Technology and the Karolinska University Hospital. And they had an idea to help patients with a weak hand grip. And if you fast forward about 7 years, we launched our first product to the market in 2013, which was called the SEM glove. And SEM stands for soft extra muscle, which is also the patented technology that we use in our industry glove. In 2015, we started getting a lot of interest from industries to use the technology to prevent injuries rather than just helping existing injuries. And when we started in 2006, we were one out of 2 research projects within the area, and the other one was General Motors and NASA. And they contacted us because they had never commercialized a research project, and they wanted us to develop their future industry glove. So since 2016, we have a collaboration with General Motors and a few other companies, such as Airbus, Eiffage, and General Electric. And we launched Iron Hand to the market in May last year. And during this year, 2020, we will finish our EU project, iHand, and we will further expand our distribution network as well as the product commercialization and the rollout of Iron Hand. So since we are a pretty small company, we need to make sure that we use our resources in the most effective way possible. And for us, this has meant that we are focusing on a few well-chosen segments. And these segments are automotive, aerospace, and construction. So within each segment, we have a partner that is helping us testing the product in their daily environment and giving us feedback to make sure that the product is actually ready for the industry market. And in the third quarter last year, we signed agreements with a few partners for distribution of Iron Hand. So we signed partners in the largest markets, which are the United States, Germany, and France, and a few other European markets as well. And as you can see in France, we have 2 distributors. So one of them, Gobio, is for purchasing Iron Hand, and Loxam is for renting out the Iron Hand. And a few weeks ago, we launched Iron Hand 1.6, which is the newest version of our system. And this upgrade is very much focusing on the user experience of the system and improving. We want the users to actually want to use the product, because we know that's a factor for success. And a part of this launch was the Iron Connect, which is a smartphone-based app for profile management and configuration of the Iron Hand glove. And this allows the operators to adjust the settings in the glove throughout the workday, but also to create customized profiles to make sure that the glove is suitable for their specific needs and their specific work task. So, what are some of the success factors at Bioservo? We always strive to work very close to our customers to make sure that we actually fill their needs. And our customers and our partners' feedback has always been the basis for our development. And we need to make sure that each customer, we take in their feedback, and then we go back and develop and further improve the glove to make sure that it fits their industry. And we are also trying to be very agile and adaptive. So for example, from the beginning, Iron Hand was only planned to be a strengthening glove. But as soon as the customers heard about the sensors in the fingertips, their first question was, can you collect data with this? And from that moment, we then started developing the digital risk assessment that we offer today. And we are always focusing on the user experience. And when we do improvements of the glove, we have the end user in mind. As I mentioned before, from experience, we know that if the user on the floor does not want to use the product, it would most likely just hang in a cabinet somewhere. So we are continuously trying to improve the product and make it more comfortable and easier for the operators to use. And that was it.
So do we have any questions for Sofia or Iron Man here? Any questions? No?
No? Okay.
Crystal clear. Here's a question.
Have they just sorry, you have to say Stuart's little sister.
I know.
Right. Do you have any contact with Shadow Robotics in London?
No. Do you think we should?
Possible. They do a robot hand, but I don't know about they have a challenge probably with the sensors that you have, so it might be interesting. They supply NASA too.
Okay, that's a good advice. Thank you. And everyone can try the glove on afterwards if you want to.
It's a great experience. Thank
Yes,
you so
thank
much.
you.
To our next speakers, just another company from the building, and maybe the currently oldest company in the building. I'm not sure.
Okay,
Pau
maybe.
has been around for a while. Started off with speeding drones or something like that. I remember he said I have the fastest drone in the world. You know, how you always think about those kind of stuff. But there was some proof points with video
we were
sports
one of
cars.
the, yeah, there were not many other products like that,
No,
so it
exactly.
was
There
easy
were
to
only
be the
one
first.
other in the world.
Nowadays different.
In Norway, I guess. No. So anyway, so this company has developed very nicely into something completely different, and I'm so happy to have you here again, Pau, and just take it away.
Yep, thank you. Okay. Good afternoon or evening for some of you. So my name is Pau Mallol, and I'm the CEO and founder of Inkonova. Inkonova develops inspection, autonomous inspection, and automated analytics for industries and industrial applications. We have been starting 3 years ago, actually, but we started with underground mining. And what we do basically is right now is we commercialize a laser scanning drone that we fly in inaccessible areas and collect 3D data and generate 3D models using LiDAR. You have here, you can take a look later, one of our oldest prototype actually, but you will see picture of the commercial unit that we just delivered last week in Chile. So unfortunately we don't have a commercial now here. But this works, and we develop a lot of software first on the prototype, and we roll it out to the commercial units later. So just in a nutshell, the problem that it's very common underground in mining especially is there are many inaccessible areas. They can come from operations themselves, like when you they blast this area, it's very dangerous, and obviously you shouldn't get in there until it's secured, which takes some time. But there are also accidents and other scenarios. So it's very common to find areas where are inaccessible, or that they are just difficult to access. They could be a big stope that is very tall, so even if you can get in, if you go with a traditional laser scanning system with a tripod from the ground, you will have blind spots and other issues. So we started in 2016 to fly manually underground drones that we develop also ourselves, and carrying a laser scanner, a LiDAR, to generate the point cloud. At that point, we basically were developing the drone that carried the payload, which, as I said, was a laser scanner. And we were flying manually, meaning we had goggles, and with a camera on the drone, or 3 cameras on the drone actually, in different directions. We were actually seeing where the drone was going, so we could fly beyond line of sight, meaning we don't need to see the drone to fly. That had several complications. First, the awareness. You see basically forward or where the camera points, but not in the back or the sides. Also about you had to really have some steel nerves and so on. These are very expensive equipment, and if you lose a drone in inaccessible areas, you lose it, literally. So also you could have chains hanging, you can have a lot of things popping out from the sides that are not easy to see. So what we, after that, we saw that we had to basically automate the operation of the drone for increasing safety, and especially for the user experience, to make it as easy to use and to be easily adopted by the industry. So we said, okay, we cannot access this LiDAR that we are carrying right now, so let's develop our own laser scanning system. And since you get 3D data in real time, you can use that for many cool stuff that I'm gonna show you soon in a video. Not to mention that you could basically base your collision avoidance on this 3D data and so on. So we started working on our laser scanning solution. And this is basically, this is a picture from Chile, the unit that we sold in Chile. So in a nutshell, you have the drone that we developed for underground. We consider using DJI and other off-the-shelf drones, which some competitors use. But there are disadvantages. First, you don't have access really to the whole software of the drone. So if DJI decides to stop offering the SDK or some access or change something, you actually might have issues there. And also, and we also learn a lot of lessons from this year's flying manually underground. So this drone is developed by us for underground environments, not as much this one, but the commercial one. And then this is a computer module and the LiDAR module. Both have are modular, can be released very quickly without any tool from the drone, and use it for handheld scanning or whatever. So this unit can also scan above ground. We have done tests in parks and power lines and so on, because the point is that we use SLAM for localization. So that's a big word that is important to mention. Otherwise, we couldn't localize the drone underground because there is no GPS or infrastructure. But the good news, as I said, is that you can also use it for above ground. So I'm going to show a quick video, if I can play this. Oh, sorry, the sound. One second. So this is what we see in the computer in real time. So we can put the drone anywhere and we see the point cloud, and we can actually, as you will see later, zoom in and out and rotate to find the best path later if you want. So basically, sorry, I will, 1 second. I actually didn't want to stop it and go forward. Doesn't matter. So what I wanted to show is that the map, the scan that you saw in blue right after the flight, this is, we use what we call dual SLAM. So we actually use SLAM for navigation and for processing the real-time data. So when we land, we just need to download the map and see it. We can see it underground and see if it went well, or we have to repeat the flight or whatever. And then the last picture, this was just one of 4 flights, and the result of this specific mission, let's say, was actually 2-level scans, which I'm going to show you in a second. So this is just a screenshot of rather old, actually. We keep improving the visualization, but this is basically what you see. You see the drone and the drone model, which is from our, obviously, design. And then it has the attitude of the drone, so you can see when it goes forward, as you have seen in the video, hopefully. This is actually a very big scan that we made in Kazakhstan for a few months ago. Basically, I want to highlight how actually quick one can actually do such long scans. Just to give you an idea, this in these drives, this is the size of a truck. Basically, trucks go in and out there, and well, you have also the scale here. But this was done in an accumulated flight time of 45 minutes, so not one single battery, but a few. And the processing time is approximately the same time than the flight time. So it was actually under 1 hour. This is actually a detail of the previous map. So we make a cut in the model, and you can see how detailed we can get it with stones and so on. So, and this is what you saw before. This is a screenshot, so the quality is not that good, unfortunately, here. But basically, the video that you saw scanned this part here. And then what we did with other flights was the bottom level, 3 flights in this, as I'm indicating now. And then we merge, we have also a script that we can actually merge maps automatically, because these individual scans, they have to be merged later. So this is the conclusion of my presentation. And if you have any question or recommendation or advice, I'm here for you. It's usually, sorry, the accuracy is, we use Velodyne LiDAR, and usually is about ±3 centimeters. It depends on a number of factors, and the range is about 100, 120 meters, depends on the environment and so on as well. Yeah, that's a good question. We actually, we are best at developing solutions and solving problems and finding problems that there are no solutions for. But right now, we are still talking to a number of local partners. Until then, we have to also service. So yeah, I have been 3 times in Chile the last couple of months. I'm going to Turkey probably this week, and next month in India. These are in talks. But yeah, both, I would say. For EU, I think we are also interested on doing services anyway, but we prefer to have local partners for mid-long term at least.
Name, please.
Olsson and did you ever consider to go underwater?
Actually, we have 2 new products that as soon as we have this rolling on its own autonomously, let's say, this business line, let's say, or product. We have actually, next is an underwater autonomous tank inspection. We have actually, let's say, the puzzle pieces are there in terms of the client to test. I have I can say that is in Saudi Arabia, actually. So we have the place where to test with the client interested. We have the local partners. We know the technology. I know who can deliver us laser scanners for underwater, which I thought they didn't exist, but they exist. It's a matter of resources. Right now, we need to really focus on the underground. But yes, so if you are in this area, in this on the underwater business, maybe we should talk. And yeah.
We have to move forward, so you'll be here for a while. Thank you so
Yeah.
much. It's just amazing to Henrik prepare himself. Just amazing to me. It's always been that this handful of guys in this tiny little office here, they sell those drones around the world in all kind of continents. Isn't that amazing? I mean, you're still in this little kind of cupboard. I think that's just amazing. And it shows what you can do if you really want to and you know what you're doing. So great to have you here. Our next speaker is not yet a things company. Right. So we're going to fix that soon. They come from the West Coast.
Yeah, precisely. Some Gothenburg dialect then on me, for sure. Yeah.
Henrik, take it away.
Thank you. So, my name is Henrik, CEO of Rebel Industries. So, I'm going to talk a bit today about what we're doing. And we actually are a staffing company for robots. And our mission is to provide appreciated, committed, and efficient workmates. So what we're going to look into is what does this mean for us? For the staffing part, how do we go to market, and what does it mean from that perspective? But also, what does this mean for what type of capabilities do we need to create to really get an appreciated, committed, and efficient workmate as we are delivering robots? So a bit about our history. We typically say that we were born out of frustration. We all stem from large organizations where we have seen that the capability exists, but typically you're not able to work across borders and really innovate because you're focusing on the next quarter, right? So we were founded 2018, and we come also from research at Chalmers University of Technology within dynamic sequence planning. So that's the baseline for our product. So we have created a software, basically rebel control, that makes it feasible to put robots to work really fast, basically. So we work with configuration and configuring skill sets for robot, and that's why we can provide automation as a service. So we joined Volvo Group's collaborative robot system laboratory, and we're helping them with quite many interesting stuff. And we just released also some of our new staff, Emil, Carl, and Ida. So Ida is a grinding robot or sanding robot, and Emil and Carl you will get to watch some movies on later on today. So enough about us, and moving into why are we doing this and why are we calling ourselves a staffing company in that sense. So the automation market today, from our perspective at least, is quite traditional. I mean, we have automation distributors. It's ABB, KUKA, Fanuc, Universal Robots, and so on. They are really transactional focused, meaning that they sell robots. They don't sell what the robot does. They sell the capability of a robot, basically. We have, from our perspective, a quite traditional integrator market with consultancy focus, and everybody who have worked with consultants know that you do a large functional requirement and large non-functional requirement, and then you do the project, and then you have a change request dialogue in the end, in a nutshell. So from my perspective, I come from the IT industry, so I come a bit from the cloud side, worked a lot with Microsoft, AWS, and those kind of companies. They have really transformed from the IT industry, not the entire industry, but they are driving the mindset of adoption. They are driving the mindset of getting paid when your product is actually working and providing value to the end client. And this is our mindset as well, and that's why we are saying that we are a staffing company from that perspective. So we want to get paid when our robots produce the value, basically. To do this, now I can't step here, but to do this, we need to reduce the complexity, of course. So we need to be really fast in putting robots to work. And that's the skill set that we have enabled through our software, basically. So adoption and usability, that's the end game, and that's why we see ourselves as a staffing company. Oh, sorry. Yeah, not used being a rock star yet anyway. So, as said, I mean, we are not the only industry or only ones thinking about the services coming. We see it in I already mentioned the cloud perspective. We see it in B2C market. I'm from Gothenburg, so we see it in the automotive sector as well. We see mobility as a service, car as a service from, for example, Lynk & Co and M, which is a new Sam fleet. I don't think it exists in Stockholm, actually. I think it's Gothenburg and Malmö. So what this means, basically, I mean, we need to take an entirely new responsibility. When we say, okay, this is as a service, we get paid when the robot is working. And of course, we want to utilize resource sharing and so on and so forth. I mean, we need to take the responsibility of having a working robot. We need to being able to give the personalization aspect of it, because you can't scale it if you can provide a personalized experience. I mean, we need to solve a specific assignment, right? So this is a quite changing environment, and this is what we always are working on how to be able to have a plug and produce concept as we are talking about, and saying, okay, what's the assignment? What is it we're really trying to do? And then really fast move in there and make our clients see that the robot can do it. As you see here, this is a typical robot today for us. We are quite agnostic in terms of what brand we can integrate to. We have started with Universal Robot, but it could just as likely be an ABB, KUKA, or whatever. And you will see later on, I mean, we talk about appreciated workmates. And to be an appreciated workmate, we think that you shouldn't be standing in a cage doing one thing all the time. We think that you should be movable. We think you should be flexible. We think you should be working with different skill sets on different stations with different articles and so on and so forth. So this is just a baseline, having the Universal Robot as a arm, but we have a 3 division. We use different type of gripping, tool changes. We have a platform for being able to move the robot with a pallet mover. We can have it on an AGV if we like to. So I mean, these type of capabilities we are introducing to the robot, and also the capabilities of being fast in implementing the robot, basically. So, but of course, with the service side, we also take a responsibility, and that's something that we always need to recognize. That saying that we get paid when our robot produces the value, then we need to produce the value. I also like to say that it's not about the robots taking the jobs from the humans. It's about the collaboration from our perspective. I mean, typically, our robots should do the work that is dangerous, that is boring, and so on and so forth. So we see the robots, we work with skills, and we see the robots as a part of the team, and we try to see it in that way, so you can work with it as a variable resource, just like a regular staffing company does, basically. So the baseline for everything in this world, I guess, is becoming fast, and fast in producing value. And this is what we try to live at Rebel. So moving into a bit more to the way of working and the solution and some movies, so you can see the flexibility in the concept. So, of course, we have a lot of benefits working with robots instead of humans in terms of the employee contract. They can basically work whenever, whatever. They don't have any ambition in life. So, I mean, what we train them for, they should be able to do and stay there. So, our concept is that we say we're actually aiming to have a robot being able to implement it in 2 days. I guess efficient time, we are like 4 or 5 days for our working installation. So we're quite fast as we work with the configuration all the time due to the assignment. But we have some lead time usually. What drives up the time typically is when we need to 3D print a tooling, special tooling for the specific assignment, or those kind of special things, or we would need to work with a specialized quality assurance vision model or something like that. Everything that is special to that case, basically. But solving the picking, the grinding, the sanding, and so on, we can do really fast in that sense. What we want to the market space that we are in is not building the large lines that are static. I mean, the marketplace that we are in is helping to automate things that humans does today that we don't want them to do, basically. So with our solution, we basically like high article variation, small batches, and with it, we also can optimize the resource planning, because if you can have a robot doing multiple tasks, basically you get your investment back in a better way, right? So that's the case. Our way of working is, it's quite straightforward. We go out, we agree on the agreements and tasks and duties, and then we do the configuration, and we either invite the client to other automation studio so they can see the robot doing it, or we go out with the robot and it does it, basically. And as we work with an information model in the entire way, we can also be really fast in the CE marking, because, I mean, it's standardized assignments in a way. So basically, I mean, it's always fun. Seeing is believing, as we say. So this is a typical case. So what you will see here, this is Patrick, our researcher from Chalmers. He's moving the robot to a new assignment with a pallet mover in this case. We have said that, okay, it should be able to do this with a pallet mover to decrease investment costs. So robot goes to this place, reads up on how did I come to the place, because you shouldn't need to be exact in this situation, right? Reads up on the fixtures. In this case, it's a pressure tester and engraving machine. And then it reads up on, okay, where's my articles, what type of articles it is, and so on and so forth. So we can recognize articles based on CAD files. And we do a lot of algorithms around optimization for how to scan the objects in the right way, depending on what type of object. And from that also determine how can we grip it, how can we work with it, and so on and so forth. So let's see. Emil is coming to its workstation and starts reading up. This basically takes 10 seconds. What it does now in the background is basically updating its entire programming in how did I come to it, how did we do the virtual commissioning and changing the configuration basically. And then it starts working. So this took us basically 2 or 3 days of work. And because we typically work with small configuration in how to scan and so on, we automate these things, but of course it's always something we need to work on. Yeah, so that's one assignment. If we take another one, just showing a bit about how you can utilize 3D printing as a way of moving fast into the client and building workstations where the client have human operators, but also robot as operators, because every workstation we build should be able to sometimes be a robot there, sometimes be a person there. So here we have 3D printed for the tooling, because we need to use the vacuum tool in a quite different way when they do the assignment. We have 3D printing the way that robot needs to work with the tooling, basically. So once again, I mean, now we didn't see the element where the robot comes to its workstation and reads up on it, but basically it reads up on what type of object am I working on, how should I grip it, and how should I work with it. Just a way for you guys to see the concept in a sense. But as said, I mean, it's just as important to understand that this is a variable workforce, and sometimes you need to plan that, okay, now we want a human doing the work, and now we want a robot doing the work. And the robot should be able to, with no turnover time, basically move to another assignment and start working with it. So I typically, what we are building, I typically do the analogy to Sonos. I don't know how many of you who are music fans, but their concept, I like it really much. When you put out the speakers, you have some in some room, some in another room, and then you do your own playlist and push it out, and you push another playlist out in another room, and then you swap them and so on and so forth. Imagine the same thing but with robots. So we configure the playlist for the robot basically, and we can distribute it fast to the robot, and the robot can change room and so on and so forth. So this is basically the same concept as we are doing here. As I said, I mean, we are based from research for discrete steering of discrete systems. So I mean, for us, we are agnostic in terms of type of robot to steer as well. This is just an example of having 2 robots managing it with an AGV as well. It's a bit of a slower movie, so we don't need to see everything, but you understand the concept. Sometimes we want the robot to move, sometimes we want the material to come to the robot. I mean, it depends on the strategy, basically. Just so you get an understanding of different types of skill sets that the robots typically have. Another thing that we are working a lot with is the user experience, and here is the IT where the IT side come in from my perspective. I mean, it's quite traditional in the automation market today, And we are working a lot with universal robots, and they are maybe seen as one of the in front of the user experience in a sense. We have lifted out everything, so we don't do any dependent programming or whatever. So we have the experience is basically like putting on your playlist, and what you can see here. So you choose your robot, basically. You choose the skill that it should have, and then you start the skill, and we configure the skill sets today. So we are building this platform. We spent 2 years building the capability of implementing robots, but now we are also building the skill set of distributing it, and of course focusing a lot of creating a great user experience in this field. So, as said, I mean, we want to provide you appreciate the committed and efficient workmates. That's the end point. And we always think about how to do this. So now we are thinking a lot about what's the next robot to support. Do we want a faster robot? Do we want a stronger robot? Or do we want something else? Because, I mean, it's all about the capabilities. So that's our next step, basically. Yeah, thank you.
Brilliant. Very good. The past is going to eat the big ones, you know, anyone. I mean, you're going to eat, because you were here 4 or 5 months ago, and
Yeah.
I'm just amazed. Different from then to today. Stuart, you have a question?
Yeah, are you involved with the latest European robot initiative in research for future industry in Europe?
No. Yeah. We are doing a lot of R&D projects as well. So.
Specific EU track for exactly
Ah.
what you're doing. I'm a member of that.
Oh, cool. Let's talk.
Any more questions?
Everything's clear. Yeah.
You noticed, one question, why were he allowed to speak 2 minutes longer? You know, that's a reasonable question, but he's come
Yeah.
from Gothenburg.
Yeah. Thank you.
We are working with about 600 Swedish small companies now across Sweden, which is quite many. They don't pay, they're not nothing actually. If they behave well, we invite them again. It's a lot about how they actually behave and what they actually do. But that's a massive kind of resource for anyone to tap onto. And then we have today 45-ish corporates that are members of things who we try to work with that part. So for all of you, whoever you are, whoever you know, spread the word about that. So if people want to work with this, then this is the place to be. If it's the physical world, if it's the robotics, deep tech, i.e. everything that's difficult, then they should be here. So you're more than welcome to talk more about that with me or Asta or Sean or whoever here. So with all that, thank you so much, and more food, I guess, more beers. Take it away. Thank you for all the speakers for sharing your knowledge.